Okay, just a second. Okay. Yeah, somewhere there. All you needed was the theorem sheet. Okay, here we go. Let me put these. I think you may have stuff from college algebra. I'll keep this. That's from the class that was in here before you. Okay, so basically the only thing that's different in this section is that you got to know different restrictions. So you need these 3 new pictures. Just refer to those as you construct your pictures. So you're going to have to put some work into memorizing those, because that one's got a hole in the middle. It's like the cosine, because secant's related to cosine, they're reciprocals, but it's not defined. If you do a secant up at 5/2, you get undefined. This one is like, let's see, this one's like the sine function because it's the reciprocal of sine, but at this one value at 0, inverse cosecant is undefined. So they have different points that they have that little hole at. And then this is cotangent. That was the one that's going to be hard to memorize. It's like cosine. These were the 3 we learned in the last section. This one was like this one, only you can't use the endpoints. This one is kind of the odd duck because it's related to it's not related to cosine, but yet it looks like the cosine graph, but you can't use the 2 endpoints. It's undefined there. So try to memorize the pictures rather than all of this mess that's in the box. That's hard to memorize like that, but if you just memorize the pictures, you are memorizing all of that. So see if you can maybe put them on note cards or something and try to memorize them. Okay, ready to do some problems? There's not much to say in this section other than I got your test, by the way. I'll get a grade for you right after this if you want to stay behind. Not much to say other than to jump into the problems. Okay, so let's see, decide whether true, true, true. Why don't we jump into the real problems? Let's start with number 3. We could go back to those like calculator problems. Okay, so I'm going to develop the drawings for you. Remember that. Try to get in your head that inverses are angles. So you're going to start off by saying to yourself that this inverse is equal to some angle that you don't yet know, and your job is to look for it. So this is equal to, I started all the problems like this in the last section. Next thing I did, I rewrote it. I rewrote it without the inverse symbol. So I was teaching you the other day that all you got to do to get rid of the inverse symbol is swap positions for these 2 right here. Get this right up against the trig word and this in its place. That's it. And that's what gets rid of the inverse symbol, because you'll be able to read it a lot better once you put it like that. So now it's going to say regular cotangent rather than inverse cotangent of the unknown angle is equal to square root of 3 over 3. Now in this particular section, you're going to have to know the relationships that I taught you back in section 6.3. You're going to have to know those really well, the special right triangles. So I'll write them here on the board so you can keep glancing at them because you're going to need them here. You're going to need to know the actual formulas because they're not going to always give you numbers that you're going to recognize right off the bat, although they satisfy 30, 60, 90 formulas and 45, 45, 90 formulas. If the numbers along the legs and the hypotenuse satisfy the formulas, then you have a 30, 60, 90 or a 45. So let's recall those formulas back from section 6.2 and 6.3. Whenever you have a 30, 60, 90, you can tell that it's a 30, 60, 90, and therefore that there's a 30 always across from the short leg. But that's only if this is happening. That the hypotenuse should be twice as big as the short leg. That's something that has to be true, as well as this. That the long leg, you should be able to get it by taking the short leg and multiplying by square root of 3. So I would check into this one first. Make sure that you have a hypotenuse that's twice as big as your short leg. And then you can take the short leg and see if, hey, when I multiply it by square root of 3, do I get the long leg? Because if you know that you definitely have a short leg and a long leg that obey these things, you are into a 30, 60, 90. At that point, what you'll do is you'll determine which of the legs is shorter. It'll be the short leg, and across from that will be the 30. So maybe you should write that. You need to actually know the formulas rather than just having numbers memorized. Say across from the short leg will be the 30-degree angle, always. And therefore, if you know where the 30 is, you automatically know where the 60 is. Okay, the other one you learned, there's only one other special right triangle. There's the 30, 60, 90. There's the 45, 45, 90. So that only had one formula. You know both the legs were equal, right? Now, they usually give it to you as square root of 2 over 2. But they can give it to you as other things. As long as the two legs are equal, and as long as the legs have this relationship to the hypotenuse, then it is a 45, 45, 90. Okay, the hypotenuse has to be square root of 2 times a leg. If that is not true, then it's not a 45, 45, 90. And they're purposely trying to give you either a 30, 60, 90 or a 45, 45, 90. Okay, I'm just reiterating for you formulas that I gave you in 6.2 and 6.3. You have to know the formulas now. Okay, let's go on. You got all the answers at the back. You can check them as you go along. Okay, here we go. Stop me if you need further explanation, although I haven't done anything yet. I was just bringing back the formulas for you. Okay, so first thing that you're going to do is you're going to take this apart, realizing that you have two pieces of the triangle already. What's the formula for cotangent? Because if you know the formula, you realize that in the right triangle that you're about to draw, you already have two sides just because of the formula. What's the formula for cotangent? Okay, so x over y instead of y over x. All right, therefore you have the x and you have the y. Okay, now let's pay attention to the restrictions because we're only going to draw our picture. See, only these two sections in this chapter have restrictions. Once I get into 7.3, no more restrictions. And in 7.4, no restrictions, and then you get into the proofs. Okay, so look at your theorem page right there. The restrictions for inverse cotangent, which we're doing, is like a sunrise, but you can't use the endpoints. Okay, so why don't we jot that down just so we are keeping that in mind as we do our drawing, which I'm about to draw right now, and put these numbers on it. Now, you can do the drawing right on here if you want to, or if you don't want to put it on top of that shape, then just do another x and y. Okay. Look at what this says here, that your cotangent is equal to a positive value. So where do you think you are? You only have these two choices, quad 1 or 2. Should I make my drawing in 1 or 2? 1. Okay, here I go. There's my hypotenuse. There's my y, or my sine. This is my x, or my cosine. Go put the numbers on there. Let me just make it smaller. Okay, so y is 3, x is square root of 3. Why don't we go and get, now, you have formulas for 45, 45, 90. I mean, I think you can imagine which one it is, right? You know it's not the 45, 45, 90, right? Because if it was the 45, 45, 90, wouldn't you have 2's and square roots of 2's and stuff like that? But if it's the 36, 90, where's the 30? Where's the 60? Because you know the only thing that really matters in the end is what this angle is right here. Because what this angle is determines what that is, which in the first quadrant is the same. So when it's a 30, 60, 90, your job is to figure out who's at the center. Is it the 30 or is it the 60? So by you knowing those formulas and using Pythagorean theorem to get that third and missing leg, because they've given you everything. All you need to do is find the third and missing leg. So you're going to go hypotenuse, I'll do it right over here. Hypotenuse squared is equal to leg squared plus leg squared, which is 12. Now, please stop me if I'm not showing you enough arithmetic. People that need to be shown what I just did, here it is. I'll put that there for those people. 3 squared, square root of 3 squared is just 3. So 9 plus 3, 12. Take the square root, take the square root, and you have, let's see. How could you break down a 12 so that you could take part of it out? Okay, good. That's called taking a partial square root. So this is 4 times 3. That's the 12 that's underneath, right? I'm just breaking it down. Let me make it a little bigger. Okay, so the 12 is the same thing as 4 times 3, right? Well, you're up underneath. But when you take the 4 out, what does it become? It becomes a 2. Okay, so we're going to put that 2 square root of 3. So we now know that our hypotenuse is 2 square roots of 3. Plop that right up here, and let's consider what we know about 30, 60, 90. Okay, let's go back and think about this. You'll see that this kind of thinking will come quicker and quicker to you as you try to get used to, hey, what kind of rationale do I have to go through? Okay, so didn't I say that if it was, you're pretty sure already that it's a 30, 60, 90, right? We just have to check. Is the hypotenuse twice as big as the short leg? Doesn't this have to be the short leg if this is the hypotenuse right here? Because isn't that twice as big as that? That determines that that's the short leg. And if you know what the short leg is, don't you automatically know what the long leg is? Because it has to be the other one. So it's a reasoning. It's the ability to reason through the formula. So this guy right here is the short leg. This one's the long leg. Now I want you to tell me which of those legs, the leg that goes up and down, or the leg that goes like this that we just said was the short leg, which one tells you the angle at the center? Long leg. Always the leg that is right here, it's across from this angle, therefore it tells you about the angle that it's across from. Isn't the long leg always across from what, the 30 or the 60? It's across from the 60. You now know what that angle is. You are done with the problem. That is your goal, to figure out the angle at the center. Now, if you're in quad 1, we're not going to always be in quad 1. I have to start you with an easy problem. When you're in quad 1, those are the easier problems because the angle at the center is the final theta, but not true when you're in other quadrants. So this 60-degree angle here is the same thing. Even though this is called the reference angle, it's the same thing as the actual theta. Get good at giving me the pi type answer for this thing. Pi divided by what? 3/4 gives you 60 degrees. What's that denominator when it's a 60? 3/4. 3. Okay, get used to that because I'm pretty sure that my math lab, they like you to give everything in pi. Once in a blue moon, they'll let you give it in degrees. Okay, so this will be 3. There's your answer. Okay, let's try it again. Okay, this time you're giving you negatives, therefore you're not going to be in quad 1. Okay, so this one is, you got to think a little bit harder about the signs. Okay, let's start off. Notice that it's very systematic here. There's a system here. Start off with an unknown angle. Okay, get rid of the inverse symbol. So it's just cosecant of theta is equal to 2 square roots of 3 over 3. Okay, now I have no inverse symbol, but having a direct statement like this rather than an indirect statement allows me to build my triangle. So now I go and build my triangle, but first I want to refer to my restrictions. I want to temporarily think of my restrictions. Look on your sheet and notice that for inverse cosecant that the restrictions look like this. You need to be either in quad 1 or quad 4. You may not stop right here. Okay, so what quad should I be in, 1 or 4? Because I'm trying to get some negatives going on, right? So I can't be in quad 1. So I'm going to put my rotating arm right here, which really represents my hypotenuse, travel up to the x-axis, and get these numbers where they belong, which you can only do if you know the definition. So isn't cosecant related to sine? And sine was what? Y over r? So flip that over, r over y. That's the definition for that. This is the r. This is the y. All right, so it's 2. Okay, 2 square roots of 3. The y will be 3. Who gets the negative? Who do you think gets the negative? The 3. Do you know that the hypotenuse and the angle called the reference angle, those are the two things in trig that are never negative. Hypotenuse, never negative. And the reference angle, never negative. So if there are negatives floating around, you've got to decide who to give it to. It can only, even though they had it at the top, it can only possibly belong to this guy. Besides that, even if you don't remember that reference angles and hypotenuse can't be negative, isn't it true that you're in a quadrant where the y's are negative? And that leg that I just put that number on represents the y. It even looks like a little y-axis. So if you can't remember that, maybe you can remember it that way. Okay, so now we're going to, just like I did in the last problem, see really the procedure that I'm doing is very repetitive. Go figure out what quadrant you're in based on the restrictions, put the numbers on the triangle, Pythag your way to the third side, and then decide where the 30 or the 60 is. You know this is not the 45, right? Because otherwise there would be square roots of 2. There's certain things that are just common sense. Okay, so here we go. We're going to figure out what's going on right there. But anyway, hypotenuse squared is equal to leg squared. Anything squared is positive, so that's going to be a 9. That, I don't know if I should just square in my head. I'm going to actually show you what I'm doing. Whoops, I did it wrong. Erase, scratch. Let me do that again. I put the hypotenuse in the wrong place. So it's supposed to be 2 hypotenuse squared is equal to leg squared plus leg squared. You got to keep the legs by them on one side and the hypotenuse by itself. Okay, so you're not only squaring the front, but you're also squaring this radical, which makes the radical just pop off. So it makes a 4 out of that. It makes a 3 out of that. Multiplied together, you get a 12. Bring this over here. It becomes 12 minus 9, which is equal to x squared. And x squared is equal to 3. Therefore, x is equal to square root of 3. Okay, which one's the short leg? The x or the y? Okay, good. Okay, whatever this is double of, it's double of that one. That has to be the short leg. So it says those formulas right here. Hypotenuse is always double the short leg. All right, if this is the short leg, I like to focus in on the short leg because right away I know what the long leg is. This is the long leg. And of those two legs, which one tells you what the angle is at the center, the short leg or the long leg in this particular problem? Okay, the long leg, because it's always the leg that runs up and down that tells you what the angle is at the center. So this being the long leg, this would have to be 60. 60 is the same thing as pi over 3. Okay, now hold on. Let's make sure we're doing this right. Because if I said it was 60, that would be the reference angle, right? What do you think I should say about the real theta? Because what I just put right here is really just the reference angle. What do you think the final answer is if you caught what I was doing yesterday? Because if I was at 60, wouldn't I really be in quadrant 1? But I want to be where I'm at with all the numbers the way they are, but I want to be in quadrant 4. There you go, right there, negative 60. So the reference angle will tell you just what that little angle is at the center, and from that reference angle, you will decide, do you have to spin negatively to get into the quadrant that you're supposed to be in, or do you have to spin way over to some other quadrant? It's going to be the first thing that it'll be the thing that you think of as you settle in on the final theta. Okay, so theta in this case, so that you're spinning down into this quadrant and never passing through these quadrants would have to be negative 60. All right, let's go to the next one. Gets very repetitive at this point. So maybe today might be a good opportunity for you to do your first little participation thing, because there's only so much of this I can take before I just go absolutely insane. I'm doing the same thing over and over again here. Okay, you let me know if you have any questions as I go a little bit further, and then I'm probably going to lose it. Okay, so here we go. Let's do a secant. Okay, watch it. I'm doing the same thing. You've got to try and memorize the procedure as you go through. First, I'm going to rewrite. That's step 1. Okay, so rewrite. There you go. Get rid of the inverse. So now I'm just going to go secant of theta. Get it right up against the secant. We no longer have an inverse, and the square root of 2 has taken its place. Now, some of you are going to choose not to go on with this problem, not to go on with the building of the triangle and doing the Pythag and all that stuff. Don't you find it unnecessary in this case? What does a reference angle have to be, folks? It has to be a 45, right? Because there's only 2 right triangles, right? 30, 60, 90. And that's the guy where you got to wonder, hey, is it a 30 as my reference angle? That one I suggest you do until you just really tip top on that. But this, it's 45. Okay, but we still got to think a little bit. At least we could get away with not doing Pythag, not thinking about what triangle. We can wipe those things out. Okay, we know it's a reference angle. Let's just write that right now. Reference angle has to be 45 degrees in this case, or pi over 4. That's the same thing as 45 degrees. All right, but we do still need to think about those restrictions, because I told you the reference angle only tells you what's right at the center in the triangle, but not necessarily the final answer. Okay, so let's just think about it for a second. I mean, in this case it is, because there's no negatives. What's the restrictions that you have for inverse secant? Look at your little theorem page. Do you see that it's like the sunrise, but there's a hole in the middle at pi over 2? So you get to be anywhere from here to here, but not right there. Okay, you could be from there to there when you draw your triangle, but anyway, where do you think you need to be, in quad 1 or quad 2 if your secant is positive? It has to be in quadrant 1. So it just so happens that when you're in quad 1, the reference angle is the same as the actual theta. That is not true in any of the other quadrants. Okay, let's go on to one that's negative. How about 7? Let's go to 7. Slight difference, but we can still cut some steps out. Okay, so let's see. We're doing secant of theta is equal to square root of 2 again. Everybody, when you're talking square roots of 2, reference angle has to be 45. It just has to be 45. So 45 I could write there, or pi over 4. Only the negatives show you the essence of what it means, what the difference is between a reference angle and a real theta. Only then can you really see what I'm talking about. And that's even if you can, get it then. All right, again, you know that we're supposed to be somewhere in the sunrise section, only you can't be at the top. I just drew the picture for you a minute ago. There it is right there. We need to be in here because we're doing inverse secant. Which quadrant do you think you should be in this time if you're going to try and get some negatives to happen? It has to be in quad 2, right? Okay, so let's get in quad 2. Draw a nice clean picture. Here's my arm rotating to quad 2. And we had decided together, without doing Pythag, without looking at the formulas, that we're in a 45 reference angle, right? Go put the reference angle there, 45. And let's try and keep it in fractions this time. I want you to practice counting in fractions because I got to get you good at that. All right, so instead of putting 45, I'm going to put pi over 4 right in there. And I'm going to try to practice with you counting in fractions. Okay, I want everybody to extend this arm. Isn't this called 1 pi? Ugh. Okay, so that's called 1 pi, right? And you see that your reference angle's in force? So let's talk force. We're going to talk in force. You know the number 1 can be written in any way that you feel you want to write it in. You could write 1 pi as 8 over 8, 7 over 7, 6 over 6, anything where the top and the bottom match. What you want to write it in is force because the reference angle's in force. And then let's see if we can get you to understand when do I add, when do I subtract. If you were rotating like this, bing, 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 and you stop because the hypotenuse is your rotating arm, and you stop right there. 1/4, 1/4, 1/4 before you get to 4/4. Should you subtract or should you add to get the real answer? You're subtracting in your head. It takes not even a second to get that answer. You're just momentarily thinking about it, but for some students, when I say it verbally and even if I write it, they still don't get that. They don't know when to subtract and when to add. Those are the students that just struggle with it. Some of you are lucky and you can think about that in a second and understand it. So I could tell you this. I'll say it another way. When you are coming up on the triangle, let's say you're in some other quadrant other than quad 1, because quad 1's easy. So let's say you're coming up on the picture. If it's so, now these things are called landmarks. Landmarks. This is a landmark, 1 pi and 2 pi, because sometimes you're going to see your pictures over here, and you're going to have to either add or subtract from 2 pi. So when you see that you are approaching a landmark, the only landmarks there are here, let me label the other one just so we could call it a landmark. This is called 8/4. Remember, I'm talking in force. If you're approaching a landmark, but you stop right before you get there, stop. Your rotating arm stops right before you get there. You will find yourself always subtracting the reference angle from where you were on your way to the landmark that you were on your way to. You'll find yourself subtracting. If you are traveling towards a landmark and you spin slightly past it, then you will find yourself adding. So like for instance, let's say this arm was down here, and I had gone 1/4 beyond the landmark. Wouldn't it be 4/4 plus 1/4, and you'd be at 5/4? So if you stop right before you get there, subtract. If you spin slightly past the landmark, add. Okay, that is also going to be true for this. Only when you're coming up on this one, the only thing you're going to do is subtract. Because if you spin past it, you're back in quad 1. All right, so we'll keep working on that as we go along. So anyway, this was called theta is equal to 3/4. So when you're in another quad, then I can get into your head what's the difference between the reference angle and the true answer. Because it's, easier to see everything that's going on and what I'm doing to get that answer. Okay, there's the picture, the reference angle, me counting in fractions, final answer. Do you want to stop me to ask anything? Okay, let's do a little bit of calculator stuff. Let's see, 8. Wait, before we do that one, why don't we do 8 before we do calculator? Because I'm going to show you a shortcut for putting the problems in the calculator that you don't have a key for. Because you only got a key for inverse sine, inverse cosine, and inverse tangent, right? And you got to make those keys work for you if you're going to do these more complicated ones. So the book shows it like in 5 steps, and I think we can just cut all that out, and I'll give you a shortcut for that. All right, let's do 8. Let's one more practice on this same procedure that I've done for every single problem, okay? We're going to be in the negative zone. We're going to try and figure out, I know there's no square root of 2's here, but I don't know. Let's just see. Let's see. Are we in 30, 60, 90 or 45, 45, 90? You may have a hunch about that one way or the other, but here we go. Same steps. Unknown. All inverses are angles, and I just don't know what angle that's equal to right now. Rewriting it without the inverse symbol. So it is cosecant of theta cosecant of theta is equal to -2. So temporarily, I want to figure out where should I be when I'm doing inverse cosecant. Look on your theorem sheet. You should be in here. So this one's a little banana belly with a popped belly button. So that's right there. You got to be somewhere in there. Where do you think you should draw your picture? And I got 1 or 4 as options. Okay, 4. So I'm going to be in 4, and I'm going to, dissect that number -2, make it like into a definition. What's the definition of cosecant? Cosecant's related to sine. All right, so r over y. R over y. Let's put that right next to the 2. So this is r over y. It's a fractional type definition, so that's why I like my numbers to be fractions. If they're not fractions, make them a fraction, because that gives me 2 numbers to then go and put on my triangle, right? Now I know I got the negative at the top, but remember I was telling you that the r can really never be negative, nor can the reference angle, so this really belongs to this guy. All right, so I'm going to be right in there. There's my triangle. I start putting the numbers on here. This is 2. This is 1. The negative belongs to that because we're in territory where the y's are negative. And I want to figure out what the x's are. If you don't know which one this is, let's just go ahead and do hypotenuse squared is equal to leg squared. Can you see what I'm doing? Plus other leg squared. Legs on one side. Hypotenuse on the other, so this is 4 is equal to 1 plus x squared. See, I don't know that you would have recognized that one. I mean, if you see a square root of 2, 45. You see a square root of 3, but you probably didn't know that it was in here. You see that square root of 3 starting to evolve in the work. So you bring this over here, it's a -1, becomes a 3, and then by the time you go like this, there you go. So you're in a 30, 60, 90. Okay, so go and put that on your, and let's check this real quick. I don't think they're going to try and trick you, but I thought I saw one problem in there that they did, so that's why I'm checking them with you. But anyway, which one do you think has to be the short leg? Yeah, so do you see how I'm always thinking about short leg hypotenuse? That's the easiest relationship to get your thoughts thinking about. The hypotenuse is double the short leg. The long leg is then based on the short leg. So you should always have your thoughts on the short leg and the hypotenuse to get yourself rolling. I noticed really quickly, and so did many of you that just called it out, that this is double that. The negative doesn't matter. Just the fact that this is double that number right there makes that the short leg. Now, if on top of that being the short leg, I suspect it's the short leg, I still have to check the other one because they could try to mess with you like that. They could make one of them work and then the other one fail, and then you can't go on with the problem because you don't have the kind of information that you need. So real quick, if you were to multiply this by square root of 3, don't worry about the negatives. Just if you were to multiply this 1 by square root of 3, wouldn't you get that? So therefore, that's the long leg. Okay, so you got a long leg. You got a short leg, and you are now going to try and figure out what is the angle at the center. Which leg matters, the short leg or the long leg in this case? The short leg. It's always the piece that goes like this, because directly across from the vertical leg, always, I don't care what quadrant you're in, will be the reference angle. The reference angle might either be the final answer, or it might require a tiny bit more thought. So let's see, short leg, this has to be 30, pi over 6. But I'm supposed to be giving an answer that's in quad 4, not quad 1, so I can't just get up and say pi over 6, because that'd be in quad 1. So what do I have to call this? What's that final answer there? Should I give that? Now that's the reference angle. And then the final answer would be, if you want to keep yourself in the restricted zone but land down here, then you got to show that you recognize that you did learn how to spin negatively. So just because your final theta is negative pi over 6 doesn't mean that your reference angle is still pi over 6. But this is the answer. So if you give me this, you would only get half credit. That means you don't realize how to use a reference angle to get yourself in the quadrant that you're supposed to be getting in. Okay, that's the final answer. Okay, calculator. Get your calculator. Let's get you to press some of these in when you don't really have a key. If I leave the final exam the way it is, this is the first question on the exam. How do you get your calculator to do things that you don't have keys for? So practice it so that you know it. I might take it off, but we'll see. We'll see. All right, so now I got that one. All right, so for number 9. Let's see if I should do it the long. I'm going to do it the long way first and then the short way. Of course, you're going to want to do it the short way, but just so you can match the answers. Okay, so here we go. We're going to go inverse secant of blah, 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 blah of 2 is equal to some unknown angle, even though we're using our calculator. We're going to get rid of the inverse key by going secant of theta is equal to 2. The way the book does it, isn't secant the same thing as 1 over cosine? So I could replace secant with whatever it's equivalent to. That's called substitution. See, this is the way they show you in the book because it allows you to then jump into the use of the cosine key by you rewriting this word right here. So you write it like this. And then I don't know how good you are with alternative versions of cross multiplication. I think most of you just know go like this and cross multiply. But really it can be used even to cut out even more steps. Like for instance, you can cross multiply just one way and you can cut out some steps. You're allowed to do this. You want to solve for cosine, right? You're never really solving for anything if you leave it in the denominator. It has to be up at the top level for you to get the true answer. So what you can do, this is a form of cross multiplication, but you are cutting out one of the steps. You can switch these two. You can let them swap places. Okay, so a equivalent version of this is this. Bring the 2 down here, let the cosine take its place. Okay, in that way, you can use your calculator now because you know if you want to go from the way this equation is written right now right back to how you would enter it in the calculator. Remember how I've been training you every time I started these problems to get rid of the inverse symbol? By just like swapping the theta and the number. That's all I've been doing to get rid of the inverse symbol. Well, you can go right back the other way with that definition. If you switch them again, the inverse symbol will be right back where it used to be. And that's what I'm going to do. I'm going to use just so I can make a calculator problem out of this, I want the inverse symbol to reappear. So just like I get it to disappear by switching these two, I can also get it to reappear by switching the two again. Now press it in your calculator. You now have a key, and then I'm going to show you the shortcut. If your calculator shuts down on you, that means it's undefined if it says quit. Now this says round to 2 decimal places. That means you wanted a radian type answer because you got to pay attention to what kind of answer you want. If you want a radian answer, which again I knew I wanted a radian answer because they said round. Radians are decimals. So if you want it in radians, put the mode in radians. If you want your answer in degrees, put the mode in degrees. Okay, so you should have gotten, let me press it in. 1.047, and then they told you to round it to hundredths place. So theta is equal to 1.05. Okay, if you want to avoid all the, the steps that I just did, where I went like this, then I, replaced secant with 1 over cosine. Whenever you're doing one that you don't have a key for, go ahead and rewrite it using, its reciprocal cousin. Secant is related to cosine, right? So go ahead and whatever the reciprocal cousin is of that, rewrite it using that. It'll still be an inverse. And then what you're going to do right in here is you're just going to, this is related to its reciprocal cousin, right? Let me try to explain this the right way. So that's why I use this one, because this is the reciprocal cousin to that, but I kept it in inverse form. But then you know the number how there was a 2 there? You also have to do the reciprocal of that. Not only do you have to choose the reciprocal trig function, but you also have to reciprocate the number that you were doing the root of. And isn't that what we ended up doing here anyway? So I can cut you through all those steps. Bam, right to the answer. If you can remember that. Reciprocate the function, reciprocate the number, both of them. And you'll cut through all of this. If that makes more sense to do it to you the long way, then do it the long way. All right. Let me see if there's anything over here. Okay, let's do 10. Everybody do 10 on their own. Let me see if you got it. Do 10 on your own. Set it up. Do it on your own. Round it to the place it says round to. Try to think of what's the reciprocal function of cotan and what's the reciprocal of -4. And you then can put it in your calculator. All right, ready for what did you get for anybody get that answer? What was it? Anybody get that? 0.24? Huh? Okay, let me just do it. Oh, Jesus. Okay, so inverse tan. Okay, I'm going to do it. I'll do it both ways for you. Right. This is not easy. Okay, here's the long way and the short way. Okay, so if you want to rewrite this, it's cotan. See, I'm slipping into madness right now in the middle of the problem. Okay, so cotan of theta, this is equal to -4. Rewrite this. Cotan's the same thing as 1 over tan. This is the long way where you show all the steps. I don't know which way you prefer. I don't know how this is different than what I just did, but I guess it is. There's the -4 right there. This takes its place. And then if you want to turn it back into an inverse, because now you have a word there that there actually is a key for. I'm not sure what I did that's different in this problem than the last one. You can maybe tell me which part confuses you, because half of you said you got a different answer, so I don't know. Let me see what answer I get then. Let's see. So if I wanted to turn this from a regular statement back into inverse so that I could plug it into the calculator, I would just go inverse tan. Just switch those two. And if you want it to come out in radians, put it in radian mode. And if you want it to go in degrees, put it in degree mode. Okay, put it in your calculator. I have mine in radian mode. I think it does say to round off for this one. Which one is this? Round to 2 decimal places. Okay, so let's see. Second inverse tan. -0.25. And I got 0.244. What's the answer back there? What is it? 2.90? Okay, so let's do this. This is what happens. You're not in the restricted area. Okay, go get your little theorem sheet right there. So I guess I give you somewhere you are falling out of the restricted area. So what was the restriction for cotan? Plop that little picture right next to the problem so we can make this answer come out 2.9, whatever was back there. So this is different. It has something more in it, an extra step. Okay, so for inverse cotangent, you were supposed to be where? Like right in there? In between there and there, but yet you got an answer that was like at -0.244 or something like that. Okay, so I don't know if you see the problem, but you're down here somewhere. Because that answer you're getting in your calculator, isn't it an angle? So they're telling you that the answer according to your calculator is this right here. So I don't care if it's a decimal or if it's degrees. If you rotate in a negative fashion, aren't you in quad 4? So you're only allowed to be in those two. I thought they were going to give you everything where you landed in the right quadrant, but I guess it's good that we did this one. So what you can think of this as the reference angle. Just get rid of the negative and think of it as the reference angle. So we're going to call, and hold on to more than just 2 decimals. Whenever you're in the middle of the problem, hold on to 4 or 5 of the numbers. So we're going to call the reference angle 0.24498. Okay, write that right underneath your picture. Now get yourself in the restricted area. We'll use that as the reference angle. And if you're in the restricted area, but also trying to get negatives to happen, which of these 2 quads should you be in, 1 or 2? You should be in 2, because there's no negatives that occur in quad 1. So you should be in quad 2 with the reference angle. Now, the reason this seems unfamiliar to you is because we keep doing it with degrees, right? So as soon as you start doing it with anything slightly different, you know, it looks a little bit strange to you. You're just doing it with radians now instead of degrees. But the same thing that we did in all the other problems. If you fall outside of the restricted area, get yourself in the restricted area. And if you're getting your calculator involved, your calculator is only going to give you the reference angle. We did everything by hand ourselves. That's why we didn't have to use we didn't use the calculator yet. So our calculator was nice enough to give us that. We're going to get into this area right here. Okay, go put the reference angle in there. Your little reference angle is 0.24498. I don't know that I'm going to get that answer, though. What'd you say it was? 2 point what? I don't know where they got that then. Okay, so maybe it will come out to be that. Okay, so this is 1 pi, right? This is 1 pi is equal to whatever, 3.14, approximately 3.14. So what was I telling you before? When you're coming up on a landmark and you're trying to use the reference angle, what did I say you should do with the reference angle in relation to the landmark that you are approaching? We're approaching 1 pi. So if you're approaching 1 pi, which would be called approximately 3.4, but you never quite made it there, should you add or subtract? You should subtract. So can you imagine what you're doing on your paper? You're trying to find the ultimate final answer to theta. So your answer will be theta is equal to the landmark that I was approaching minus that little itty-bitty reference angle. 0.24498. What's that come out to be? Nice. All right, so here you go. This is your first participation. Get out a piece of paper. You may use your notes if you want to. You can talk to each other if you want to. Actually, before I do that, you know what I got to do? I have to do one more. I'm sorry. I don't want to do one more, but I have to. I just saw the last 3 problems where one function stuffed into another one. I need to do one of those. Let me do one of those so that you have an example of every single thing on the worksheet. Okay, let's go to the next one. Let's do like 16, I guess. Composite functions, the last like 3 are like this. What did I just do? I just did inverse tan of 4/5, secant on the outside. That's number 16. All right, here's what you're going to do for these. You're going to have to do these by hand completely. Okay, you're going to use Pythagorean theorem. You're going to build maybe you should label this. For all the ones that look like this, an inverse stuffed into another one, you're going to build a triangle for this. When you go to do the homework, try to notice, you must have noticed by now, though, that when you go to do 15, it's exactly like the 15 that I did. When you go to do 16, it'll be exactly like the 16 that I did. It'll just have different numbers, okay? So you can use this outline that I'm giving you to exactly do the homework. I haven't picked problems that are different from my math lab. So go build a triangle for this. Go ahead and rewrite it like I did for all the other ones. It's just right now, what you have is equal to, as all inverses are, an angle. They're all equal to an angle. You're never going to get a chance to figure out the actual theta, but you don't need to, because we don't know anything about triangles where there are 4s and 5s on the sides. We know 30, 60, 90. we know 45, 45, 90, but if it's a 4 and a 5 and a 3, you're never going to get the theta. But like I said, for a composite function, all you need this for is to build the triangle. All right, let's get rid of the inverse like we always do. First, we say that the inverse is equal to some unknown angle, and then we write it in the non-inverse form. Okay, then I try to recognize the definition of tangent. That's y over x. I begin to build myself a triangle that is in a quadrant where tan is positive, but that also, you know, obeys the restrictions for inverse tangent, which if you look on your sheet, where are you supposed to be for inverse tangent? That was from last section right there. Here's a little picture of inverse tangent. You can be in quad 1 or 2. All right, so let's see. I want my tan values to be positive, so I think from the two quadrants that I had to pick from, I'm going to go in quad 1. Okay, this was the restriction for inverse tangent, that you could be anywhere from here to here. I always consider that. Again, once we get out of this section, section 1 and 2, there will be no more restrictions. Then it's just full on solving trig equations. I don't care where you spin. You can spin anywhere you want. And you will have, some of the answers are going to be in all 4 quadrants. So anyway, I'm going to be right here. I'm going to go put the values on the legs. My y is 4. My x is 5. Does everybody know the 3, 4, 5? Oh, no, this won't be it. Because if it was a 3, 4, 5, the 5 would have to be on the hypotenuse. Okay, I'm going to have to do this then. All right, so it's hypotenuse squared is equal to legs squared plus legs squared. This is 16, this is 25, this is 41, this is r squared. R is therefore 41. Square root of 41. So right now, what I built in the middle is this. I built a triangle that has a 4 here, a 5 here, and a 41 here, and a theta that I am never going to find out what it is. Go put the word on the outside now. Drop down that word and continue the problem. So off the triangle that we just built, which we began like with that inverse statement in order to build the triangle, now we're going to answer the final question. What is the secant using the triangle that you just built? So secant definition is, let's see, has to do with cosine. So r over x. The r is the 41 that we just struggled to find. The x was given to us. It was 5, and that's your answer. Okay, so that includes 7 or 8 of the main problem, and then several of the calculator problems, and one of the composite problems. Okay? Now I want to see what you can do. Hold on one second. Okay, do that one. I'll put up here how to label your paper. I'm going to give you one other one besides that one. That one won't take you too long. Put this title at the top of your paper when you get a chance. And I want to see your drawing, the numbers along the sides of the triangle, all that. Everything that I've been showing you. I want to see how you rewrite that, follow all the same steps that I gave you. Hold on. by the restrictions. Like you're doing number 2. We'll go look at the picture for the restrictions for what that problem start off with, inverse cosecant. So you should be looking at that picture. And when you're looking at that picture, see how you can be either here or here? What answer did your calculator give you? Because if it gave you an answer, remember, what your calculator is giving you is an angle, right? So it told you to rotate to some kind of negative theta, right? Doesn't that fall into one of the restricted areas? I think you're okay. So you don't need to do any of that addition or subtraction. Just because I gave you an easier one. Like you fall right in. You just give me like what you got there. Circle your final answer for each of those problems. Try to move it off to the side and circle it, or just circle it so I know what is your work and what's your final answer. And then please put this title on the top. and then put what this participation quiz is about. It's on 7.1 and 7.2. These were from 7.2. That was from 7.1. So put that this is participation